Hey there, pre-calc people. Let's finish this section. This 2.7, we're going to do examples. Well, we won't finish it, but we'll get close. We're going to start off with doing example 7. All right, so now we're going to use a table to do these functions. We have our f, we have our g, we have our h. So let's do it. A says find 2f of g of 2 plus 3g of h of 0. It looks worse than it actually is. Well, let's do it. So I'm going to start inside and go outside. So g of 2, when I plug in 2 for g, so I'm looking at this. When I plug in 2 for g, I get out negative 3. So that value is negative 3. So I'm doing f of negative 3. Now what's f of negative 3? So I'm going back up here. What am I? You knock it off. What? Hold on. Alright, pause this. Well, that was goofy. So I'm going to plug in negative 3 for f, and I get negative 4. So I get 2 times negative 4, which is negative 8. Plus, now I go over here, what's my h of 0? So I look at my h of 0, plugging in x. H of 0 is 3. And then I'm going to do 3g of 3. So I look at g, I plug in 3, I get 2. Plug in 3 for g, I get 2. So that's 3 times 2, which is 6. Negative 8 plus 6 is negative 2. So remember, we're using this table. This top row tells me what to is what I'm plugging into this function. All right, let's see another one. Maybe I'll use a highlighter this time. So first thing I'm going to do is h of g of negative 2. Not again. So g of negative 2. So I'm looking at g, and when I plug in negative 2, I get negative 1. So now I'm going to do h of negative 1. So I'm going to go to h, negative 1. And where do they intersect? 1.5. So h of negative 1 is 1.5 because I'm plugging in my output from one in for the input of my other. All right. So now I'm going to do f of g of 2. So I'm going to do g of 2. Now g of negative 2, so I'm going to do a g of 2 is negative 3. Ooh. So I'm going to do f of negative 3. All right, this is getting kind of messy. Messy, messy, messy. That's from a movie. So I go negative 3. I'm doing f of it. So that's negative 4. It's kind of like a puzzle. Okay, negative 1.5. H of negative 1 was positive 1.5. I don't know why I wrote negative. Sorry about that, guys. 1.5 times negative 4 is negative 6. Okay. Now, if k of x is absolute value 3x minus 4, for what values of x is k of x equal to f of g of 0? All right, so first thing I do is find what this value is. So g of 0 is 1. And f of 1 is 4. So they're asking, when is this function equal to 4? So we do absolute value 3x minus 4 equals 4. Now remember, the absolute value, we have to set up two equations. That's why we slipped this in here. we have to do 3x minus 4 equals 4, and 3x minus 4 equals negative 4. Okay? And I need to solve both equations, because there's going to be two answers. So I get 3x equals 8. So x equals 8/3, which is one of our answers. And over here, I'm going to do plus 4. And I get 3x equals 0. So x equals 0 is my other answer. So we actually have two values. Because remember, the absolute value we have to set up, or set it equal to the positive and the negative version. Okay? Okay, one in the books. Let's look at example 8. We have a composition of functions. Describe the transformation. Okay. So our g of x is x minus 1. So I'm doing f of x minus 1. So I'm going to plug in x minus 1 in for x to get f, or that would be x minus 1 squared. All right, so do we know what x squared looks like? It's a parabola, right? That negative 1, though, is going to move it to the right 1. So that's right 1. From my parent function, I'm treating f of x like my parent function. Okay? Or actually, all of them, we're going to be messing with x squared. Okay. Sorry, that was obnoxious. So here we're going to do my h of x is 2x. So I'm going to do f of 2x, which would be 2x squared, because f of x is x squared. So my 2 is in the parentheses. So that's going to be a horizontal dilation of a half, or a shrink of a half. Because it's 1 over what's inside. It's horizontal. So when I draw it, it's going to be skinnier. Half as skinny, actually. All right? This is just a nice review of our graph transformations. Now let's do g of f of x. Ooh. So my f of x, stop it. I'm sorry. My f of x is x squared. An email. So I'm going to do g of x squared. So I'm going to plug in x squared in for my x. I get x squared minus 1. And now this one, the minus 1's on the outside. So I'm going to go down 1 and draw my x squared. There we go. Not too bad. I'm going kind of quick, but y'all are smart cookies. Smart cookies. Okay. Let's keep trucking. You gross. Alright. Let's complete this table for f of g of x. I'm going to go kind of quick on this one, okay? So, I'm going to plug it in g of x first, and then plug that into f of x. Okay? Alright, let's do it. So, g of negative 4, I go g of negative 4 is 2. And now when I plug in, and then my f of negative 4 is negative 4. I'm just straight plugging the negative 4 into each respective thing. Now, for h of x, I take my 2, and I'm going to plug it into f of x, right? So, what's f of 2? 1. So h of x is 1. Okay? let's make our life a little bit easier. That's how I would do if I was just looking for one individual point. But if I'm doing a whole chart, here's what I'm going to do. I'm going to do all my f of x's first. So f of negative 3 is negative 2. F of negative 2 is 0. F of negative 1 is 2. I'm just plugging these x's into this graph. We're looking at this graph. F of 0 is 1. F of 1 is 0. F of 2 is 1. F of 3 is 2. F of 4 is 3. Okay? Just straight looking at the graph. G of negative 4 was 2. G of negative 3 is 1. G of negative 1 is negative 1. G of 0 is negative 2. Ooh, a half. What you doing? What you know about? I missed a 0 here. G of negative 2 was 0. I don't know why I plugged in negative 1. I skipped it. My bad. That's negative 1. G of 0 is negative 2. I skipped one. I got off. That would be negative a half. That'd be negative 1, negative 2, negative 3. Okay? Now that I have those, it makes h of x easier because I'm going to take, for each h of x, I'm taking my g of x and plugging into my f of x. So like for this one, my g of x goes to 1, and then when I plug in 1 for f of x, I get 0. Okay? Let's do that again. So, follow the mouse. So my g of x is 0. And then I'm going to take 0 and plug it into f of x. And f of 0 is 1. Okay? Again, I'll actually write it out this time. So I'm doing g of f of g of negative 1. G of negative 1 is negative 1. And f of negative 1 is 2. Well, that one actually, they're next to each other. Okay? G of 0 is negative 2. F of negative 2 is 0. Okay? This one's tricky. G of 1 is negative a half. F of negative a half is, well, oh, that's negative 1.5. Jiminy crickets. So negative 1.5. F of negative 1.5 is I'm getting 1.5. I think the answer key's wrong. All right, it's 1.5. Okay, I'm gonna get 2. That's a positive 2, and negative 2. Okay, and now when I graph that, it's gonna look like 1, 0, 1, 2, 0, 1.5. 2, 0, negative 2. So it's going to be like whoopie doopie doo, wee 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 wee. Wow. All right. Sorry, that was awkward. All right. One more to do. Let's get through. One more to do. How about you? I don't know. I'm going crazy. But don't ever let yourself get lazy. All right. All right, let's find f of g of f and g of f of x and use the domain and see if they're equal to each other. This is going to come up in a few units. So let's try it. So first I'm going to do f of g of x. I'm going to do this a little bit quicker. We should be getting pretty good at this, or really confused. So I'm going to plug this in for this. So I'm going to do cube root of x plus 1 cubed minus 1. Now what happens if I cube a cube root? They cancel, right? So I get x plus 1 minus 1. What's 1 minus 1? It's x. F of g of x is x. Okay. Let's find g of f of x. So now I'm going to plug this in for that. Wow. So I'm going to do cube root of x to the third minus 1 plus 1. So I flipped which one I plugged into each other. Now if I'm adding and subtracting, I don't have to worry about those parentheses, right? Eep, eep. X to the third minus 1 plus 1 is just the cube root of x to the third, which is x. Now, I have to ask myself, what are my domains of each of these? The domain for everything is all real numbers. Domain is all reals. So they match back and forth. So I can state that f of g of x equals g of f of x. It's true. Jared Gerf. That means they're inverses. They're inverses. And that's what the next unit's about. All right, let's do this one. I'm going to plug them into each other. They look close. So I'm going to do f of g of x first. Plug this in for that. So I'm going to do 1/3 times 3x plus 9 minus 3. Distribute 1/3 of x, or 3x is x, 1/3 of 9 is 3 minus 3. 3 minus 3 is x. Okay. Let's do it the other way. G of f of x. I think these are going to be inverses. Alright. So now I'm going to flip which way I'm plugging it. I'm going to do this in for that. So I'm going to do 3 times 1/3 x minus 3 plus 9. Distribute. I get x minus 9 plus 9. My 9's cancel. I get x. Are they equal to each other? Yes. The domains for both are all real numbers. So again, they're equal to each other and inverses. We did it. I was supposed to give you a non-example, but that's fine. We'll talk more about that later. I hope you enjoyed. Hope you have a good life. Peace.